Okay, so here we go. Let's get started. My name is Rafael Sene. I'm from IBM Brazil. I work as part of the Power Systems organization. Currently work on the Cloud Squad, doing different set of things there, especially on Cloud Private, and more recently work on OpenShift on Power. So today I'm going to talk about a little bit how anyone can get access to Power for free. And there's different set of configurations that you can try, different environments, and here we go. So, So just talk a little bit about me. So moving forward, if you need to talk to me, just my mail or reach me out. This, in fact, is me holding a Power 9 processor. It's a real one. And today, how are we going to make your journey to Power easier? And that's important because this one, the fast pace of new open source projects. If you look at this picture, this is going to tell a lot about what's going on recently, especially on the Cloud Native Foundation. There's a bunch of new projects that emerge from all the place. And usually, those projects are born on x86. And for us, working on Power, we have the hard work on. If a project start to get too much attention, and then it is considered to be should be running on Power, we start engaging the community, or we start to doing the builds. And then the last step is to, once we have ported, tested, and have done everything that we really need to do to make that project run on Power, we need to start contributing back the changes. And this is the process that takes a long time. Eventually, the community may not accept Power as a first-class citizen in their list of supported architectures, and we may end up using alternatives like hosting that packaging in a different place, or putting that in an FTP server or anything like that. And that does not work well, because every time we have a new update in the community, and the community moves fast, we need to go there, update the package, doing all the tests again, and kind of we are locked in this cycle where if Power is not accepted as a first-class citizen in a specific community, we need to do our jobs and get that package put in some place where people can use that. For instance, this is my last attempt to add support for Power in an open source project. So I have a patch living there for about 1 month. It's a very small patch, and no answer so far from the maintainer. This is for RESTkey. RESTkey is a solid backup tool that are used by Velero. Velero is an open source tool also that's used for backup and restoring data from Kubernetes cluster. And Velero used by IBM Multi-Cloud Manager. So there's a chain of dependencies that we need to get solved to get that to work on Power very well. This is one of the parts, and to overcome the situation, I had to build this by myself, host it at Unicamp, and the other guy working on Velero had to use my pre-built package to contribute the changes back to Velero. We know that this is important because the adoption of open source software comes from developers organically downloading, using it. So that happened with Velero. When people start using Velero for their backup, to backup their Kubernetes environment, it became a well-known tool that anyone wants to use, and that was not running on Power. And then we had to catch up and trying to make that runs on Power. So making developers life easier and to ensure that they can have access to Power is critical, so they can add the support as part of their working day without too much effort. I would say at least we should be providing easy access so they can do the multi-arc stuff without any big issues, I would say. So the world is multi-arc. We cannot be locked with a specific architecture, considering that the most important one and forgetting about the other. So Power is there. Power is Power is the two fastest computer in the world. So this is the place where developers should be to be developing and deploying their application. So let's start talking about how we can multi-arc all the things on Power. This is the first chapter. And the first chapter, I will talk about the Power SDK. Back in 2011, we started developing the SDK. Basically, the idea behind that was that I can collect the knowledge of those people that are experts on Power, create a set of tools, and make that available for developers so they can use that for porting their application to Power. So as part of the SDK, we had a tool called Migration Advisor. By the way, this is the chart that I presented back in OpenPOWER Summit in 2016 about the SDK. The Migration Advisor was a tool that we developed so you could import your source code, C and C++ inside the SDK, run verification, and Migration Advisor would point where your application could fail on migrating from x86 to Power. Eventually, we would provide a quick fix for a specific issue. Then just pressing that link, you could convert the code from x86 to Power automatically. But that's the first step. But back there, the access to Power was not that easy, so we had to do something else. And what we did was to integrate QEMU user mode and the IBM Power Simulator. So using QEMU user mode, anyone could cross-compile their application on x86 and run that on x86 as a process. That worked. And we also integrated the IBM Power Simulator. Back in 2016, it was only the Power 8. This is simulates a real Power machine. It's, of course, slow, but that helps if you do not have a Power machine around. So you can get started right away without the necessity to buy a machine. This was an Eclipse-based IDE that, at the end, we converted to a set of open source tools that are available at GitHub. Anyone can go there and clone and start using. But the SDK is no longer under development, so we stopped at that. It's still available, and anyone can use. But the SDK was not enough, and that takes us to the chapter 2, which is free access to Power. So with free access to Power, we could somehow create a flowered field where developers can get the resources they need. If you are asking, the developers are the bee, and the resources are the flowers there. I believe you have seen the presentation that Klaus did a few minutes ago about Unicamp. And at Unicamp, we did the mini cloud. Basically, an OpenStack environment where everything runs on Power, and you can ask for an account there. We are going to approve, depending on what we're going to do there. And that's it. Power machine for free. We have another environments like Oregon State University that you can go there and ask for resources that are freely available, and that's important. So instead of having only a tool that anyone could use to try Power on your x86, now you have a free access to Power. So you can start a virtual machine, log in that machine, and do whatever you want. We started very small. I'd say back 2014, only 11 users, a little bit concerned about where that's going to end. And eventually, the community starts using that. We realized that were free resources available for Power, and they came. So we have a bunch of developers from different communities. Not those communities does not use our resources as their main resource for Power, but developers, when they need to port or they need to test something on Power, eventually they ask for us for a free virtual machine. So since 2014, we have more than 1,000 requests. which is considered a good number for a mini cloud. And we continue growing. So those requests, usually people do all sorts of things like make software multi-platform, enable software on Power somehow, study Linux, and that's important. Because when we do offer free access, and when the free access is no longer a solution for this specific community, they buy Power. And that's what's happened with Mono. They used our resources for several years, I would say, for free. And when the free resources were no longer enough for their needs, they decided to buy a Power machine. So free access creates sale opportunities. This is cool for IBM or for the partners that are playing, playing or make Power a accessible system. But cool, is this enough, I would say? Providing free access to Power, having a tool that people can use it to migrate their applications to Power or simulate Power on x86 machine? Unfortunately, no. And that takes us to the chapter 3 of our journey, which is we need to be where developers are. If you want to make Power, if you want to ensure that Power is the first-class citizen in the development world, we need to ensure that we know we are where they are doing their job. Essentially, those developers here will be the ones making decision about which server to use, which application, how beneficial it is to use multiple architecture. So we need to ensure that they have the opportunity to play with the fastest architecture in the world, could say, and we should make that easier. And by being on where developers are, I mean that we should be here at GitHub and GitLab. We have more open source tools, source code management tools like Bitbucket, but these two are the most used ones. And I would say GitHub is the biggest one. We all know that. And we should be there. We should be part of that. And to ensure that when a new project starts or someone wants to do some POC or whatever they want to do with a different architecture, we are there. Power is there. That we should make that easier. So start with GitHub. The first and the easiest way to get your builds on Power at GitHub is using Travis.ci. So we have Garrett here, who is working directly on that. And Travis is a hosted service that we can configure and start building your application very quickly. It's easy to configure, it's easy to maintain, and it's used by a lot of people. You can say that Travis is the most used CI tool out there for open source projects that are hosted at GitHub. So you can see that by this big number, this is a huge number. So this is one of the safest places that we need to be. If you want to succeed with Power, with the open source community, we must be there. And to start the build on Power using Travis, all you need is this flag. We have another one called architecture, but this is also will get you building on Power. And how you do that? That's pretty simple. So step 1, log in the travis.org. Simple. You can log in with your GitHub account. Step 2, enable your project. Also simple. Just turn on Travis for your specific project. Step 3, this is the most important part. This is the recipe that's going to be executed by Travis. So this is a very, very simple example just to show how we can do that, how you can do that. You need to create this travis.yml recipe, and inside this file, we are going to describe what's going to happen with your build. This is a very simple build example how you can do that, but we have a more complex one like this one, which is used by, the ski boot, the OpenPOWER ski boot. So they are using Travis to test their software on different set of operating systems. And you can do that. So you can expand that and do whatever you want on Power. So So in this case here, let's go a little bit. In this case, he's building on x86 and on Power at the same time, basically executing the same set of commands on both architecture, validating the same architecture at the same time, validating different architecture at the same time. When you start in building, you configure your project and you start building using Travis, you can see that you're going to see this in your pull requests or merge requests, and this indicates that Travis is doing something with that specific piece of code that was submitted. And when you do that, so when you start to build with Travis, you can see that you can log in there. You see the progress of your build like this one. So this is the small example that I showed to you. So this is just uname output here. So you can see that this is PPC 64. So first, this is the first tool. Works very well. You can talk to Garrett if you want more details about what's going to happen. But this is available. It's in alpha, so is not publicly available. So you can start using that. That's going to be interesting to see you're using Travis on Power. So more documentation about that is here, just to learn how you can increase your recipe to start and build on Travis. So also, this is a case that we have internally at IBM. We also have a Travis Enterprise deployed, and at IBM we have added the capability to build not only on x86 and on Power, but also build on Z. So anyone inside IBM can build on the three architectures at the same time. We started with Travis at IBM back in 2017 as a requirement for the IBM Cloud Private development. So we would like to make Power at the same, have Power to have the parity with x86. So to do that, we should join the journey that they were doing for ICP and be where their developers were. So that means that those developers were using Travis, and somehow we should be there. So we started to integrate that back in 2017, as I mentioned. So it was required for ICP development, IBM Cloud Private development, and today we expanded that so anyone inside IBM can build on Power. And that's interesting because again, like we did with Unicamp, providing free access to Power, this happened inside IBM too. So when people, so important note, we didn't disclaim this internally. So we didn't send an email or didn't publish anything internally saying that you can build on Power using Travis at IBM. People start to discovering this by themselves, and today we have more than 200,000 builds on Power, and not only for ICP, but for instance, we have a project doing doing a set of tests for the Linux kernel on Power using Travis. They have a bunch of recipes that do all sorts of things with a new kernel that's going to be in the next operating system that's going to run on Power. So that's interesting to see. People are using. So what we did, we just offer something that developers really wanted to use, and they start using that. So that's very interesting to see happen inside IBM. So this is the integration between GitHub and Travis CI. But we have more. So people does not like GitHub because, I don't know, it's now a Microsoft thing, and they can somehow be using GitLab. And GitLab is similar to GitHub, where you can host your source code there, but it's better on managing a software release. For instance, you can go from the source code management to managing issues and doing the CI/CD there. And they have a software called GitLab Runner, which is an agent that runs in your server, and this connects to the GitLab master, I would say. And when this process is completed, it started to listen for build requests. So the good news is that this GitLab Runner was written using Golang, and that runs on Power out of the box. So you do not need to do anything else make this, to start the building on Power using GitLab. So how you can do that? First type, sign in your GitLab account. This is the point where GitLab is different from Travis.ci. On Travis, you do not need to provide your backend. Travis have their own servers, and when you use Travis, you just need to configure your recipe there. For GitLab, you need to have your server. And this is interesting, especially if you want to have some particular configuration, like you want to use GPUs, or you want to have a server with a specific configuration that is not available on Travis, for instance. So yeah, this is where they are different. So you need to provide your own backend to start using GitLab. And for instance, here in this example, I'm installed that on a Ubuntu machine, virtual machine at Unicamp. So for this example, I'm using a virtual machine at Unicamp where I got my VM and installed my GitLab Runner. Then I need to go back to my project at GitLab and configure that. So go to the CI/CD, go to runners. Then I'm going to have here a path plus a key that I should use to connect my server to this GitLab master. When I do that, so I have a steps to execute. So basically, do the configuration, setting the correct URL here, and this is the most important one, the flag. This is, as we saw in Travis that we have that OS tag, here we are going to use the Ubuntu PPC64. You can define your own. You do not need to use this, but this is just an example of how you can do that. When you configure your GitLab Runner to connect to your GitLab master, I would say, you're going to see this one. So, oops, sorry. For my project, I have a specific runner, dedicated runner, that's only will build jobs which contains this flag. So this is my Power VM attached to my project in GitLab, and this will enable me to do all sorts of testing and building and whatever I need to do on Power from GitLab. So similarly to Travis, you need to describe a recipe here, a YAML file. There's no one-to-one porting from Travis to this file, so it has its own syntax, so you need to just take a look on documentation how to do that. But in this example, so I have set the tag Ubuntu PPC64 like I have configured in my initial steps. So when I do this and I send a pull request or do the traditional development workflow, it's going to build my project on Power. Oh, it's hard to see here, but I promise this is PPC64 and yeah, so this is how we can build on Power using GitLab. That's interesting because, again, like we did with Unicamp, like we did with Travis externally and Travis at IBM, we offer this as a possibility. So there's no charge for people doing that. Go to Unicamp, go to OSU, grab your own VM and start doing that. And the interesting part is that when we did that, people start using, like this guy. We have a thread on an issue at GitLab repository where we want them to formally support that on Power or add Power listed as a supported platform. And this guy is part of that discussion somehow. When I joined the thread saying that, hey, I tested that on Power, it works, I got my VM at Unicamp and did all the tests that required, that guy saw the link, and he asked for a VM at Unicamp. He started using that, and he enabled his project called C unit on Power. So this wasn't expected at all, but this is a good result. So people started using by getting the knowledge about how to do that. And this is important. So very simple steps, very easy steps on how to do what we need to do on Power. So there's no blocker. So the resources are available, so anyone can do that. And in the case of GitLab, you can get more resources here to understand how you can configure your build script using GitLab. So what next? We tried the SDK, where we put together a set of tools, a tooling mechanism that would help developers moving from x86 to Power. Then we enable people to use it, to have access to Power for free using the clouds, the public clouds, I would say, that we have in some universities around the world. And now we are somehow trying to be part of the party and join developers where they are. I would say that the basic layer is there. And of course, we need more power. So maybe more resources available, easy available, so people can get the resources even with easily, I would say. Better documentation, so as sometimes adding support for a different architecture is not trivial, especially if it's a given community or project or the people work on those specific projects are not familiar with this one. So convincing them that it's basically the same is not enough. So we need to have a better documentation around Power, how to do the porting, how to maintain somehow your software, how to do basic stuff like create a virtual machine, or using Docker. Can I use Docker on Power? Of course you can use Docker on Power. How I can do that? So this is a frequent question that I receive. I also received a question from a guy asking if Power was an operating system instead of architecture. So basic question that should be a better, good place for an answer. And this is part of, I would say, our work today to get better documentation and better information around Power so people can access that easily. And of course, we need more advocacy. So we need people to engage in more developers, join conferences, talk about Power, talk about the possibilities on Power, well, how they can do that, how they can use that. Talk about that Power is not, let's say, it's not different from x86 if you are using Linux. So porting now, that's Power little ending, so it's easier just to recompile your application. So of course, if you need to tweak that for performance, that's another story. But that should not be an issue at all. So we need more advocacy, we need people talking about that, and we need to spread the word about Power. So with that, so this concludes this presentation. So thank you, everyone. So I hope you now understand how easy it is to build on Power. If you're part of any open source community and you want to start adopting Power, you know where the resources are, you know how to build on Power using Travis, you know how to build on Power using GitLab. Just start doing this. So thank you. Questions? Do we have questions? No questions? Okay.
I've been following the GitLab project for PowerPC binary properly, and they're following those issues. They're trying to, I found that I had to build my own binary for it.
Yep.
And I don't know if you've been tracking the upstream issue about it, but they're trying to solidify how they manage all the other different architectures and so forth. So
Yeah.
that's one issue that I ran into.
Yeah. We have another company, not IBM, that built the package for Power. And especially, they built the GitLab Runner for Power to be installed on RHEL. On Ubuntu, is supported by default, so you do not need to do anything else. And yeah, there is a big thread on trying to get that formally supported, and so it's taking too long to evolve. All the pieces are there. We just need sign off from the GitLab folks on getting that available. So yeah, it's not an easy task for like any other port into Power. So they need to support something that they're not familiar with. So yeah, we just need to continue trying, and talk to them about that until they are convinced that, okay, this is not a big deal, so let's do this and support and put a 18-hour website. But yeah, that's the easiest way to get power. GitLab is the easiest way, so today. No, Travis is the easiest. GitLab is almost there. More questions? No, okay, so thank you.
Actually, I will ask you a question, Rafael.
Okay.
How often do you think we run into communities that simply just haven't thought about multi-arch? Meaning,
No, that's how often? All the time.
so, but how many times is it a real issue in structure of the tree, those sorts of things, as opposed to just, they just need to take and they just need a place to take it, build it, prove to themselves that Go language
Yeah.
runs everywhere, right? Or runs wherever you build it.
Yeah.
Right?
So, well, we have a bunch of issues recent. So, I'd say REST is one, Valerio is one. Docker has become an issue for us, I believe, on getting multi-arch.
With respect to packages
Yeah.
in Docker Hub,
No, the binary itself.
the binary itself, okay?
So we have much more. If you look at that landscape for the cloud native.
Yeah, how come you didn't color code it for what was available and what wasn't on Power?
No, that's just the landscape.
I'm talking about the one with all the packages. You really
Did-
should have color coded that, which ones were.
I think he did.
Oh, okay.
The bright red ones are on Power.
This one? No.
How come you didn't color code?
No, this is not color code. This is what they provide as their main web page, like all the software that are part of the Cloud Native Foundation somehow, and they can be incubating or graduated, and this is not listed by architecture. This is just an example of how quick that kind of cloud native software evolves, and we cannot keep up with that if we do not have those communities adopting Power by themselves. We do not have enough arms to do the porting all the time.
No, I agree with you wholeheartedly, yeah.
And this is just to illustrate that. So this changes not all the time, but you can visit this page monthly and you see that there's new software here. And eventually this new software will become a new thing. And this new thing was born on x86, and eventually we need to get that new thing on Power, and then we start to get that new thing on Power. Oh, there's a new release of this new thing. Oh, this new thing is now the older thing, and the old thing, and we need to start work with another one. So it's an endless catch-up situation. So we need to start to good advocacy on engage with those communities. So if you're using Travis, let's try Travis on Power. You can allow Travis to fail on Power if you need to avoid your builds to happen. But let's start. So step by step, baby steps. Do one thing. Oh, enable Travis, configure a build test case, and eventually your software will be running on Power the same way it's run on x86. That applies for any other. So I see that. So you can see, so at Unicamp, we have a bunch of repositories that we had to build some of these applications, like containerd. What else? Well, Docker, we have to build Docker and made it available at Unicamp recently because the latest version was not there. So, yeah.
So, that gets to my point. Things like Helm, all they would need
It's build.
is Travis.
Yeah.
Or all they would need is a CI.
Yeah.
Kubernetes needs a whole language environment
Yeah.
like Go. If you don't have Golang enabled, that's what you love on Docker
Yeah.
or Kubernetes. And so, there are different levels
On necessities, yeah.
of investment needed
Yeah.
to get these things. And the
Yeah.
question is, how many of them, I guess another way of asking the question is,
Yeah.
how many of this do you think would cover just with the CI environment?
So
50%, 80%?
much more, as you say.
So do I take a stab at this? I've got a team that's been porting open source software for about 5 years now. We port about 3,000 things that are outside of the distro. 80%, the biggest changes was to update the configure script for them. Once Power was added to 6408, 80% will pretty much work with minimal tweaks. The other 20% runs the gamut from little bits of assembly code mixed in, poor architecture, community that refuses to accept another architecture, like Google's Chromium community will not accept the changes that Raptor and we have been working on. Some are just, they just won't accept it, so we've got out-of-tree changes forever at the moment. 20% though, it's still an 80-20 rule inside of that 20%. Right? 80% are not hard, but they might take a week of work. And another 20% actually require work. And that work is all over the map. Sometimes it's tree is poorly laid out, like we were just talking about, where it can't accept changes. Sometimes they have whole modules that are written in Intel assembly. Sometimes they use features like, this is not a good example, but he's used MySQL and MariaDB wasn't quite there. So as part of their overall infrastructure, so the whole thing wouldn't come together. It's kind of a mess, and we're knocking them down one at a time. So there are about, like I said, 3,000 reported outside the distro of varying sizes. Almost all of what we get. More so now, it's new projects, like you were just saying. We've got a bunch of things feeding us new cognitive software that didn't even think about getting it productization level on one architecture, and we're asking for a second architecture. So they're kind of like, I don't know what to do with all this, but yeah, I mean, they're open to it sometimes they're not. It's just new community stuff. We're knocking them down. If we can keep them in place with travis.ci, then at least we'll get some maintenance for those communities, and it will stay current.
Travis.ci and a little bit of documentation to get started, probably cover your first 80%.
Right, now I remember I produced number 3,000.
Yeah.
That's out of the 1.1 to 2 million GitHub projects.
Yeah,
Yeah.
So close.
close.
Yeah, most of those are just models.
Today we have 100 million repositories there.
Yeah. And if you actually go through them, there's a lot of dev projects,
Yeah.
a lot of company-specific or individual projects. So if you read it down, you're probably in the 2 million.
Yeah.
Yeah, you're right.
Yeah, there's a point. So, yeah, and I believe that everyone here uses GitHub. They are not using GitLab. So
Right.
that's Travis is the best option for them.
Have you seen, I've been seeing a lot of other projects having a mass exodus away from travis.ci since the acquisition.
Yeah.
Moving to Circle.ci, has there been any?
Circle.ci is more for web development, I would say. Sorry?
I've been seeing a lot of other projects moving towards it.
Yeah, but so I believe this is very focused. Yeah, I never use a Circle.ci. I see all the way I'm watching a YouTube video, I see their propaganda on my face. But yeah, I never used that. I'm not sure if this fits our needs here with this community. I don't think so. Travis is a good option. If Travis goes away for some reason, we still have GitLab, but people are on GitHub, so we need.
So another data point there, we did an assessment roughly 3 years ago, so that's before this exodus. That assessment said 42% of all projects in the industry were using Travis.
Yeah.
32 to 35 were using Jenkins. And then there were something like 100 other CI environments that each had 0.25%. Right? It's a huge world out there, and trying to port them all would be a headache. Circle.ci was actually a bigger flip than Summit, like 0.5% or 1%. But it's still almost nothing compared to trying to boil the ocean out there.
Yeah, I believe up to date, Travis is the best place to pay attention
I
to.
think it still is. There are some valid questions about
Yeah.
that position. We talked to them directly, and they sound like they want to go all in on support of power and continue what they're doing. So I can't speak to their company strategy.
Yeah.
Us so far, it sounds
Yeah, so I would say, at IBM, when we started using Travis for ICP, we didn't miss any release. So every release of IBM called Private was launched at the planned date and time, and all the builds were there on the 3 architectures, Power Z and x86. So we reduced the amount of work by enabling Power as part of their developer workflow. So instead of doing X first, then test Power, they were doing developer, they're doing testing on Power and X at the same time. So and that's time saver that we cannot imagine. How important is that? So yeah, that's beneficial. So we need to spread this, that making our software multi-arc is not hard and save times. So this is, I would say, the most important resource we have. So if we can do one thing at once and that works for everything you need, that would be the beautiful word for development. Let's see. So we are making progress. Let's see where is the next chapter for us. Okay. Thank you.
Thank you.
Thank you.